All right, today's lecture is going to focus on how to write chemical formulas of ionic compounds. Now, in order to do this, you're going to need to have access to your Chem Helper. On your Chem Helper, there is an ion table, which is written right above the word chemist try. Also, all right, so we have three different types of compounds you'll be able to write formulas for. The first is binary compounds, in which mainly the metals come from the S block. Elements in the S block tend to have only one charge, or what's also called an oxidation state. If you have an element that's in group 1, it is always going to have a +1 ion charge. If you have elements in group 2, they will have a +2 ion charge. And that's it. When we get into the S and the D and the P block, many of those elements have valence electrons in multiple different orbitals, and therefore they can form multiple ion types. And that's what we'll get into when we look at the second one here coming up in a short form. Now, again, with an ionic compound, the first element you're going to have is going to be the metal, the second is a nonmetal. So we're going to look at chemical formulas which are going to have one element, which is X, and one element, which is Y. In ionic compounds, the X is always a metal, and Y is always a nonmetal. Now, there may be subscripts here that follow each of them. A is the subscript of X, which would be how many of X's you have in one ionic chemical formula, and how many B's or how many Y's you have. Those might be 1s, they might be 2s, they might be 3s, so on and so forth. But those subscripts come from once we see the charges. All right, so let's start doing some practice problems, and I'm going to have you then do some pause the lectures and try to do the remainders as just extra additional practice. All right, sodium chloride. A very easy one we've worked with many times before in class already. Sodium is Na, and if you look on the ion table or understand that it's in group 1, it has a charge of +1. Chloride is the nonmetal chlorine, and again, whenever we have ionic compounds, the nonmetal, the element Cl is named chlorine. But whenever we do ionic compounds, the nonmetal, we always change the ending of the second element, and it always ends in "ide." Okay, so chloride tells me it comes from the element chlorine. Chlorine is in the halogen family, and elements that are in group 17 always have a -1 ion state. And again, you can look those up also on your ion table in your Chem Helper. Since the charges are equal, this compound will form in a 1-to-1 ratio. So the chemical formula would be just simply NaCl. When you are done, the chemical formula should not have any charges left on it. When we write chemical formulas, they should not have or possess any charge because the summation of the charges adds to 0. So it would not be right to have Na +1, Cl -1. That would not be the correct ionic formula. So we want to have the ending formula have no charges on it when we're done. All right, let's look at the next one. Magnesium. Magnesium has got a charge of +2. Iodide comes from the element iodine. It is a halogen. It has a charge of -1. Now, when the charges do not match, we do something which is called cross-dropping. The subscript on the I will be a 2 because we'll cross-drop it, and then the 1 will cross-drop the there. Now, we don't need to put a 1 after the magnesium because it's already implied. If there's Mg there, the implied value is 1. If it's not 1, then we have to add whatever it ends up being. So in this case, the chemical formula would be Mgi2. 1 magnesium for every 2 iodines is the chemical compound magnesium iodide. All right, let's look at another one. Aluminum is Al. Look up the charge. The ion form of aluminum is +3. Oxide comes from the element oxygen, which has a charge of -2. Cross-drop the charges, and we get the chemical formula Al2O3. Because we would need 2 aluminums and 3 oxygens, because each aluminum would be +3, and each oxygen would be -2. And when we add up those 5 ions, it adds up to 0. And again, we're looking for the lowest ratio of ions that adds to 0, and that is what's called the chemical formula of the ionic compound. All right, now pause the lecture and do the next 3, lithium nitride, barium phosphide, and strontium sulfide and see what you get. All right, hopefully you had the following chemical formulas. Lithium nitride, cross-dropping, we get 3 lithiums for every nitrogen. Barium phosphide, cross-dropping, we get 3 bariums for every 2 phosphides. Strontium sulfide, it would not shock me if some of you might have Sr2S2, but 2,2 would be able to be reduced. When you have the ionic compound, it should be reduced down to the lowest ratio. 2:2 can be reduced down to 1:1, so this would be an incorrect answer. So again, when the ions are equal and opposite, they will form a 1:1 ratio. All right, next type of ionic compound that we're going to look at is those that contain a transition or p-block metal, in essence a D or p-block element. Now, in those, if you look at those, and if you did the ionic naming sheet from last time, you'll notice that a lot of these elements have multiple ion states. Iron, for example, can be +2 or it can have ions of +3. So just simply saying iron chloride is not sufficient because the key question is which one. Is it the iron 2 ion in the formula or is it the iron 3? Each of them, we do have both iron 2 and iron 3 of the different compounds, and they all have a unique set of chemical and physical properties. So the Roman numeral tells us the charge on the iron. So iron 3 immediately tells me that it's iron with a +3 charge. Chloride is a halogen, which has a charge of just -1. Again, cross-dropping, we now get 1 iron with 3 chlorines. And there's the chemical formula of iron 3 chloride. All right, next one, lead 4 oxide. The 4, again, tells me the charge on it is +4. Oxide has a charge of -2. Cross-dropping, we get Pb2O4. And many students would stop here, but then again, remember what I just told you about with strontium sulfide. The ratio of ions needs to be the lowest chemical formula possible. 2:4 is not the lowest ratio. We can reduce this down by 2 each. The correct formula of lead 4 oxide would actually be PbO2 because 2 oxides at -2 would balance the single +4 ion of lead, and therefore the ratio should be reduced down to 1:2. 2:4, again, would not be the correct answer and would be marked wrong. Okay, chromium 2 bromide and tin 4 nitride. Pause the lecture and go ahead and see if you can get these formulas now. All right, chromium 2 is a charge of +2. Bromide is a halogen, -1. Cross-dropping, we get 1 chromium for 2 bromines. Bromides, I should say. Tin 4, again, the 4 tells me the charge on the tin is +4. Nitride has a charge of -3. Cross-dropping, we get 3 tins for every 4 nitrogens. All right, last thing. We can also have ionic compounds that contain a polyatomic ion. For those of you coming into class in this next cycle, you'll be doing a worksheet on polyatomic ions, what they are conceptually, and how we can predict on naming them. Again, this is where I would recommend. So, when we look at that, the polyatomic ions, because they contain multiple elements, these are going to be ionic compounds that contain 3 or more elements in their chemical formulas. Okay, now one thing you'll notice with chemical formulas is that all the previous ones so far, they tended to second element tended to end in "ide." So if I have bromide, "ide," that tells me that it's just the element bromine in its ionic state. A lot of the polyatomic ions, however, contain ates and ites because we have oxygen with them. Okay, and an example of this would be bromate. Bromine bonded to 3 oxygens. That covalently bonded group of 4 elements has a single -1 charge on it. So if you see an ate or an ite at the end of it, it more than likely contains the root word of the nonmetal, which in this case is bromine, brome, and the ate or ite tells you that it has oxygen with it. So when you look up the ions in the chemistry helper, for those of you that are trying to wean yourself off of the ion table that I've supplied to you, then you just got to look up ions that contain oxygens with that element and then figure it out from there. The general rule of thumb: one of these ions is called nitrate, the other is called nitrite. The rule of thumb is that the ratio that has less oxygens ends in ite. The one that contains more ends in ate. So NO3 minus 1 is called nitrate. NO2 minus 1 is called nitrite. And nitride, from the previous one, if it ends in ide, it's just nitrogen by itself. And if you look up the charge of nitrogen, it is -3. So if it ends in ites or ates, the one that has more oxygen ends up being the ate ending, and the one with one less is the ite. Those couple of things should make it fairly easy for you to identify which ion is which on the chemistry helper. All right, so let's take a look at this. The first one we're going to do here is ammonium chloride. Ammonium is the only positive polyatomic ion, and because of that, you are going to quickly remember it. Ammonium is NH4 plus 1. Chloride ends in ide, so I know it's just simply chlorine. It doesn't have any oxygen with it. Chloride is -1. And again, because they are equal and opposite, it is a 1-to-1 ratio. So the chemical formula for ammonium chloride will be NH4Cl. All right, next one, sodium phosphate. Sodium is Na plus 1. Sodium is in group 1. It only has one oxidation state, plus 1. Phosphate, we see it ends in ate. So therefore, it has to have phosphorus with oxygen with it because it ends in an 8. And looking at the ion table in your chem helper, there's only one polyatomic ion that contains phosphorus and oxygen. And that's PO4, and it has a -3 charge. So you should never get phosphate wrong because it's the only one that has phosphorus and oxygen together. Cross-dropping, we'll need 3 sodiums for every phosphate. Na3PO4 is the chemical formula. All right, barium nitrate. Barium is Ba. It has a charge of +2. It's in group 2. Again, group 2 is always +2. Nitrate is NO3 minus 1, as we just saw. Cross-dropping, we get 1 barium and we get 2 nitrates. Now here is a problem. When we need more than one of a polyatomic ion, if you were to cross-drop, right now this literally looks like we need 1 barium, 1 nitrogen, and 32 oxygens. Right away that shouldn't be like, something's wrong here. This doesn't look right. Whenever we need more than one polyatomic ion, we have to put it in parentheses because I don't need just 2 more oxygens, I need 2 more nitrates. So if you need more than one polyatomic ion, you have to utilize parentheses around it so that you double all of the substances and not just one of them. All right, let's do one more. Iron 3 hydroxide. Iron is Fe with a charge of +3. Hydroxide is OH minus 1. We need to cross-drop. And many students would stop here, and believe it or not, this is wrong. Why is it wrong? Because, again, the 3 would only apply to the hydrogen, which would mean that we'd have 1 iron, 1 oxygen, and 3 hydrogens. But I don't need 3 hydrogens, I need 3 hydroxides. Hydroxide is a polyatomic ion because it contains both oxygen and hydrogen. So we do need to put it in parentheses because I need 3 OHs. And right there is the chemical formula for iron 3 hydroxide. Fe parentheses OH 3. All right. Okay, let's go ahead and do now the other 6. I'm going to pause the lecture now. I'm going to fill in the answers. When you are done trying these problems, start up the lecture, and before your eyes, all these will be answered for you. All right, so copper 2 sulfite. You see sulfite, it's not ide. Again, that one little letter is a big deal. Ite tells me it has oxygen. Sulfite is SO3 -2. Copper 2 is +2. So again, they're equal and opposite, so it's a 1-to-1 ratio. CuSO3. Aluminum chromate. Aluminum's got a charge of +3. Chromate is -2. Cross-dropping, we get 2 aluminums and 3 chromates utilizing parentheses around the chromate. Potassium permanganate. Potassium is +1. Permanganate is MnO4, -1. Again, the charges are equal and opposite, so there's one of each. We get potassium KMnO4. Nickel 2 is nickel +2. Chlorite is ClO2 with a -1 charge. Cross-dropping, we need 2 chlorites for every nickel, utilizing parentheses. Silver carbonate. Silver is Ag with a +1 charge. Carbonate is CO3 -2. Cross-dropping, we get 2 Ags, 2 silvers for every carbonate, Ag2CO3. Lastly, magnesium hydrogen carbonate. For the sake of this unit, I'm primarily not going to use the word magnesium hydrogen carbonate. Instead, I'm going to say magnesium bicarbonate. Whenever you see the prefix bi in front of a polyatomic ion, an anion, bi means that H plus was added to it. So bicarbonate means I'm going to add a hydrogen ion to carbonate, which is, along with adding a hydrogen to it, it is also going to cause the charge to be added 1 to it, and therefore go from -2 to -1. So bisulfate, sulfate is SO4 -2. Bisulfate means I add a hydrogen to it. Bisulfate would have HSO4 -1. Again, the charge would reduce by +1 because we're adding a hydrogen ion to it. So whenever you see the word bi, that means add a hydrogen to it. And again, all of these ions are on that ion table present on the chem helper. All right, so once you write the formulas, check the charges. If they don't match, cross drop. If it's a polyatomic ion, put parentheses around it. And that's pretty much it. If you can write the formulas of the ions down, I'm pretty confident that you'll be able to write the chemical formulas of all these different ionic compounds. And that's the last learning target in this unit. So again, continue to get practice doing this by doing the worksheet problems. I have a homework set of problems on this, that please do that, and a supplied answer key to check your answers with. We'll also be doing some practice in class for the next week or so, leading up to the test in ionic compounds and metallic compounds. All right, thanks again for listening. I have supplied with you in Canvas this ion table. It's in Unit 4 along with everything else. It says ion table to use for the rest of the packet. And unlike the ion table in the Chem Helper, with this one, along with having the formulas of all the ions, and again on the left side you've got all the positive guys, on the right side you've got all the negative guys, but you also have the names of all the ions. This sheet obviously will make naming and formula writing very easy, and what I would recommend, especially for those of you that might have a goal of taking AP Chemistry next year or in the future, that you try to wean yourself off of this sheet and only use the Chem Helper in order to figure out writing chemical formulas. You are not going to be asked to name compounds for this year, but you do have to write formulas because it's important when you do chemical reactions. Being able to write formulas from word grammar equations and then being able to balance those. So with that, this is something that may be very useful, especially if you struggle early on, to be able to look at. But beyond that, try to make use of just your Chem Helper if possible. Looking back at this sheet of the ion table, most of the polyatomic ions are the negative guys. There is only one positive polyatomic ion, which is ammonium. A polyatomic ion is an ion that contains more than one element that when they bond together covalently, they end up developing a charge of either positive or negative. So we have more than one type of element that has a single charge on it, and then it forms an ionic bond with either another positive or a negative ion. Okay? Which I've supplied to you again in this unit that you can use. They are also